and maybe more direct answer to your question is that I am going to want you to be able to describe the differences between ECC and FCC. And those would be the size of the unit cell, the density of the atoms in the unit cell, and then we talked about the sorry, I'm drawing a blank, about the general characteristics of BCC versus FCC, and that BCC metals are the harder metals, and FCC are the softer metals. We'll talk, as we get further into the term, we'll be talking more about those differences, but for now, those are the ones that matter.
Mm. Okay. Yeah, fine. Thanks for this question. Thank you.
Sure. Looks like you're in, Reese. Anybody have any other questions? If you looked at your homework and have something that didn't make sense or an example in class? Been talking specifically about metals and their properties and such. And I can't remember exactly how I worded this on the board, but when we looked at mechanical properties, there were some properties that are a function only of the strength of the bonds in the metal, and some that are a function of more than just that. And properties that are a function only of the strength of bonds can't be enhanced, they can't be modified, they're constant. And the example of that is the slope of the elastic region. Let's see, it's been a while since I've used this. So we got plastic behavior and elastic behavior. And the difference between the two is that when you have plastic behavior, there's permanent deformation, whereas with elastic behavior, whatever stresses are put on the metal, whatever strain that happens from those stresses is relieved when the stress is removed. So the difference between the two is that plastic behavior is defined as being permanent deformation. So the location of one atom with respect to another atom under stress is permanently changing. Whereas with elastic behavior, the atoms are being pulled away from one another, but not permanently. So with elastic behavior, this is just only determined by the bond strength. So for mechanical properties, the thing that's only determined by the bond strength is the modulus. Whereas with plastic behavior, these are the things that you measure on the stress strain curve that aren't within the linear or the elastic region. So when the permanent deformation is at 0.2% or 0.2% offset yield strength, that's something we measure. That's a function of plastic behavior. The ultimate tensile strength is a function of that plastic behavior. ductility. That was the, kind of like strain, the percent of permanent deformation. The toughness. I think those are, oh, hardness. So measuring any of these things requires there to be some permanent deformation. You have to permanently deform the surface to measure hardness. You have to permanently deform from impact to measure toughness. The extent of permanent deformation, that's ductility. So all of these properties are a function not of the elastic behavior, not of the bond strength, but of separating or relocating atoms. And so these properties, these can be engineered or improved or optimized. Whereas the elastic behavior, the elastic properties, they are given. You know, you choose when you're thinking about how much your material for your application can deform under a certain stress, that's modulus. And that, you know, you might have a specification and then you're limited to which metals you can use based on which ones have the modulus that would work for you. So modulus, the ratio of the applied stress to the resulting strain. Okay, so when we're, let's see, how do I go to the next page? It's just like so basic, I can't remember now.
I can also put captions if you want captions.
So, that's the sort of, gosh, I can't think of the right word. The quality or the characteristics of deformation. So now that we know that if we want to know more about deformation behavior and how to optimize that, then we should be able to have a load versus extension curve, and from that curve generate stress versus strain curve, or at least from that curve be able to measure ultimate tensile strength and yield strength and modulus elasticity. And so I went through a lot of different ways of doing that, with the hope that you would find one that was most convenient or that made the most sense to you. I'm gonna do this example. I'll use the one that makes most sense to me, but I want you to ask me or to stop me if you want me to use a different method or if another method